Hello, everyone. Welcome to this coffee break. Today, and we're going to discuss about this new version of Magnifi 5 that just been released 2 days ago. We worked on a long time for this, many hours, many months, many years of development behind this version. So I'm excited to present some of it today. So my name is David Veilleux. I'm the product manager for our tubing technologies at Eddyfi. So a lot of new things with Magnifi 5. Today, what I will discuss, go a little bit more in details. My goal is to explain first what is the AI technology we just introduced for ECT bobbin data. Then I will show you how it is easy to set up in just 7 clicks. And finally, what to expect from this true technical innovation, this groundbreaking new feature, new possibilities for tubing inspection around the world. So we're going to discuss, and of course, I will have time for your questions at the end. So let's dive into this AI technology. What is so it's used in many industries and in various forms. Actually, AI has a big shoulders and includes a lot of things. One of them is machine learning. Machine learning is the principle or the concept of building a complex mathematical model that will create a relationship between input parameters and output results. Particularity is that it is doing a learning from experimental data using an automatic learning process and statistical method. In real life example, I will show you if we take if let's say we want to design a model, an AI model with machine learning to identify cars in a picture. So first step is going to be to train it. So we're going to do first a training database. So we're going to identify cars that we believe that are most common. So a 4-door sedan, SUV, pickup truck. And we're going to add many pictures that are kind of in those models to make sure that that's our kind of initial training database. Then on the other side, engineers will develop that model, that mathematical complex structure using state-of-the-art techniques and everything. So after this model is developed, then we're going to train it on this given data set. So we do this, it's a process. Once it's done, then we need to validate it. So what we're going to do is we're going to have new pictures of similar cars, but are different. So we're going to show it kind of to the model and try to see what's the output results. So is it able to identify the cars correctly? If so, then we're good. We can say it can generalize. If not, well, we need to train it on new pictures. So we're going to have more. If the pictures we showed it's okay, then we might want to expand to more types of cars. So maybe other shapes, some of the less common cars. For example, a convertible car. Then we're going to train the model with these types of car, and then again verify the output. So if our model detects them, then it generalizes. But then if it doesn't, and we want to add those cars to our database, then we start the retraining process once again. So we're going to say, well, we're going to add these cars, maybe it's different scenarios, different colors to our training data set. We're going to rework the model and try to test it. Maybe also we can decide that, well, maybe sometimes those cars are really particular for now or for the moment. Let's not focus on those very, very specific cars. Some of them are old models. Some of them, you don't actually know what it is. So maybe we can wait for a little bit before training the models and focus on the more generic and broader expression of what is a car. So this is really the continuous process behind it, where we add new cases, new cars, new setups to the training database. We rework the model, and then we revalidate it again and again and again. And that's the key behind this machine learning process. For the AI ECT tubing, this is exactly what we've done. So we created a training data set on thousands and thousands of indications based on Ask Me best practices. Then we validated the results of our model. We tested it on new data, and then with those results, we improved the model over and over until we achieve a certain level of results that was satisfying for us. But it's always continuing. What it means into Magnifi is that if you have your data set that is displayed, then we have a patent pending detection process that's going to run as soon as you stop your acquisition or you process the file with AI. It's going to find, it's going to position, and it's going to mark the beginning of the end of any relevant indications, and all that under 1 second. So what you will see in the interface for ECT bobbin data is that you will identify the tube sheets, you will identify the support plates, and the potential location of indications. So these are not reported defects. This is just a suggestion of indications that might need to be looked at furthermore. And as you can see, the report indications that are there done by the analyst remain there in a separate column and visually are different. Within Magnifi, we integrated in a very simple to use setup. It only requires 7 clicks to activate the AI. So it's really fast, honestly, easily under 2 minutes, you're able to get peer review, peer validation of any of your data that you have. Training on these new features, about 10, 20, 30 minutes, simple, easy to understand. And just to point out that this is not an auto analysis tool. AI findings are only suggestions that must be reviewed by a certified analyst. So now I want to take the time, because it's really easy to set up. I want to take the time to show it to you in real time in Magnifi. So here I have my data set with a few tubes in there. This is my calibration tube. All I need to do to activate the AI is run through the setup. So I have the Smart Setup tab here. I'm going to start my wizard. Of course, it's just telling me that it will apply changes to my current setup. This is good. Then the first window will let me select the package. So in this case, only ECT bobbin data is supported. Then we go to the type of exchanger. This particular case, it's a straight tubes, so the probe comes out at the end. However, I just want to mention that we support different 2 other types also. So if there is a restriction at the end that prevents the tube to come out at every tube, we are still able to do the detections, and we are also able to do U-bend inspection with rigid probe. So it's only the straight sections that are inspected. So if I go back to my model, I can select it. Then I enable the AI indications. I can choose a labeling, and then just some cursor repositioning. If some of you are familiar with the Eddyfi or array channel, where we kind of create a slew, this is the same idea. AI to present the indications where they are on your data. It just needs to reposition them on a specific channel. But very, very often the default differential F2 is more than enough and does a very good job at repositioning them. If I click on finish, I get a little warning. Only thing I need to do is calibrate my true wall hole. So I position my cursor. I will go here. So this is the initial step that all the analysts do every time anyway. So no extra step here. And as soon as I calibrate my hole, I will have my findings that are appearing on my screen. So as you see this, so this is my calibration tube. And if I open the real data file, it will automatically points out the tube sheets, the support plate, and the potential location of indications that I can highlight like this. So as you've seen, very, very quickly, we can get up and running with this new feature. Switching back to my presentation. Now, what to expect with this initial version. So this model has been on active development for over 3 years. I point out by design, by the technology. This is continuously trained and improved to reach higher performances. The training is actually performed by our own AI dedicated experts. This assures that we have a very good database. We are very rigorous on creating a relevant database for the learning. And then it assures also that we have a standardized results through all the versions and the people using it. This is really the initial step towards the possibilities that AI can bring to tubing inspections. What are the requirements to using the AI ECT detection engine? So, of course, you're going to need an octane, but you can have Magnifi 3, 4, or 5, the data that can be acquired with it. Of course, to analyze the data, you need to be in 5.0, but the data can have been acquired with a previous version of Magnifi. And you need an NFI bobbin probe to certify the signal that we can use. Also, we need to follow the ASME calibration best practices. What I mean by that is, first, the F90 frequency must be optimized for the tube material and wall thickness. There are 4 frequencies with optimal distribution based on the F90 or prime. This must be present in your setup. Calibration tube is required and must include a through wall hole. As you saw, this is the calibration that needs to be done for the AI to generate the findings. And the rod channels must remain in Eddyfi's default naming so it can map everything correctly. In the database, this version is developed on common non-ferrous plain tubes. We have many tube materials in our database, and the most common ones we have are stainless steel 304, 316, and Admiralty brass and titanium. Just want to point out that I know it's still very popular, but the duplex, so mildly ferrous material, is not supported with this detection engine. Most, again, variety of wall thicknesses, but the one we've seen the most are gauges 16 and 18. I'm talking about wall thicknesses of 1.65 millimeter and 1.25 millimeter. What about the defect findings? So we can see small pitting, small defects. One that speaks to larger erosion, larger indications that are greater than 51 centimeters or 20 inches. The engine has a harder time and picks them, has a harder time picking them up. And for the moment, defects on their support plates are not covered. For complete description of capabilities, I invite you to visit our Magnifi 5 release notes section. So whenever you go to the download page of Magnifi, in the release notes, there is a reference there where you can dive a little bit more on those expectations of the current model that is in 5.0. So is that it for Magnifi 5? Of course not. We worked a lot on it. We have a nice version that is going to increase confidence level in productivity. We have other tools. I'm talking about report entry keyboard shortcuts. This has been requested for quite a while for our power users, so I'm excited that we finally have this feature. But we also have validation of full tube length data with AI. We got data list sorting and filtering, and we got a new grouping feature, and as well a new license activation via cloud to let you enjoy a dongle-free life. All these other topics, I will cover them in the next coffee break. I think it's about in next month, beginning of next month. I'll be here again to present, to dive a little bit more into these new features that support the AI and the analysis process in general. So now this is the time for your questions. Will my data be automatically collected by Eddyfi for AI learning? No, your data stays on your computer. It is local, so there's no automatic upload. However, we are more than welcome. You are more than welcome, and we are very looking forward for more data. If you believe in this tool, and we want to be the first one, be part of this new technology, I invite you to contact us and share data. We use this anonymously, and we only do this as the database for the training to make the algorithm stronger, and cover more cases and benefit and increase the benefits for all analysts out there, inspection companies, but always also asset owners, with increasing the reliability of the detection. Does the AI learn as I'm analyzing the data? No, the data as I presented is going to be fixed in capabilities for a given version release node. So it's as I say, we want to keep this training done by our Eddyfi experts. We we want to assure that the quality of the training that is done, and we want to standardize the capabilities as well. So whenever you analyze with the AI, it will not learn from your previous call. If you think it could be improved, there's cases where you think it should be there, then you are more than welcome to share your experience with us, so we can all learn from it, and improve the algorithm. But everything is going to be done by our dedicated AI engineers at our Eddyfi offices. So another question, will this new version of Eddyfi be able to filter out noise at certain angles or ignore indications at specific angles due to noise? The AI by development will do these actions without diving too deep into the details, but by design, the model developed has learned on noisy data and has kind of learned on what is noise and what is a defect. So that's really the key there, to identify the indications without calling to the noise. However, sometimes the limit is very thin, and it's sometimes the system will overcall a little bit the indications, but we don't want to hide them. So that's why we introduced the grouping feature. I will cover it in the in future version, or we have information more in depth on the website about it. But the grouping is there for those types of cases where if the user qualifies a group of indications with certain parameters, for example, that in your specific case and that noise level of tube, you say any indications above 0.3 volts with a given phase range, these are non-relevant indications, then they will be grouped in that section. They will not be hidden, but it will be able for you to see those indications only in a group, and let's see the ones that are more important in different groups. Will the use of AI channels affect the calibration I will normally use? No, so the AI only requirements is going to be the through our old calibration. So if you open a currently done setup, and then you already calibrated your calibration curve in it, if you recalibrate the whole, of course, it's going to change a little bit the parameters, but it's not going to affect your whole calibration curve. You do not need to recalibrate all the indications every time. So it's done independently. And the AI, what it does as well is that it creates its own channels for analysis. So whatever you have, your 4 frequencies, your parameters, your calibration curves, and everything, it's in there. The AI will not affect those. It will create new channels on the side to perform multiple operations and then present the indications on your own channel. So I think that's it for the questions right now. If you have any further questions, I invite you to get in touch with me. I'm looking forward to getting your feedback on this new technology, and make sure to tune in next month, beginning of next month, for more information about the other new features that are available in Magnifi 5.